negative, it opens down. Down, maximum point, ends approach negative infinity. They just keep going down forever and ever and ever and ever without an end. These are just specific values that match this graph, not super important. And then you could read through these, but this is very important. The function is decreasing from here until you get to the minimum. Because as the x values get bigger, the y values are getting smaller. So we would say that it's decreasing for when x is smaller than 2 or less than 2. But then after it hits the minimum, it starts to increase. So the function is decreasing, it hits the minimum, and then it is increasing. Because as the x values get larger, the y values are going to get bigger. And the ends on both ends, they both approach infinity. So it's decreasing, then increasing. Now this one's going to be the opposite. As x gets bigger, y actually gets bigger. So this is increasing when x is less than 1. And then it turns, which is why we call this the turning point. It turns at 1, and then it starts to decrease. So we would say the function is decreasing for all values in which x is greater than 1. As x gets bigger than 1, the outputs get smaller and smaller and smaller and smaller. So that's our second vocab kind of pair of the day, is increasing, decreasing. So let's do one more question together, 2 more questions, excuse me, and then we're going to wrap this lesson up. All right, so we're going to describe the end behavior of these graphs. If you want, if you feel up to it, pause the video, see if you can fill this in, and then replay the video and see if you matched what I am about to say. All right, since this is facing down, I'm going to throw some arrows on there. The ends are going towards negative infinity. It is increasing this way. It's getting larger until it hits a maximum point, and then it's going smaller. So I like to draw in the axis of symmetry. Sometimes this is helpful. The axis of symmetry is x equals negative 2. Why is that point important? Because all the x values to the left of this, as it grows, it gets larger, and then when it hits that, it starts to decrease. So it's increasing to the left of the axis of symmetry. So we're going to say when x is less than negative 2, on this side, it's increasing. It hits the turning point, or the maximum, and then it starts to decrease. So as x is larger than negative 2, it will start to decrease. And lastly, the range is all the y values that are less than or equal to the highest point here, which is at 4. The largest y value is at 4 because the vertex here, the vertex is negative 2, 4. All right, so if that one made sense to you, pause the video. Now's a great time to do that. Try this one all on your own to see if you're understanding it. All right, I'm going to throw some arrows on here because there should be arrows, so excuse that. All right, the end behavior. The ends are both opening up towards infinity, so they're going to go up forever. It is increasing. Well, let's draw on the axis of symmetry. The axis of symmetry is x equals negative 3. Right? So it's increasing to the right. You don't have to draw this line, and I'm just showing you that. To the right of x equals negative 3. So it's increasing when x is greater than negative 3. But all the x values, as x gets bigger, the function is decreasing. It's going down, down, down. Now, some kids get confused. They go, why is this arrow going up and this arrow going down? This arrow just indicates that the range is going up forever. But when I'm talking about increasing, decreasing, I'm talking about x values. As the x values increase, what's happening to the y values? So you have to look. As the x values increase, the outputs will decrease until it hits my lowest point, and then as my x values continue to increase, my y values will increase. So x values, you got to look left to right on the x values. So you're looking on the x values as you move left to right. What is happening? This is a good question to ask. What is happening to the y values? So left to right on the x values, as you move left to right, what is happening to the y values? Are they increasing or are they decreasing? All right, so it's decreasing when x is less than -3. And my range is going to be greater than or equal to the lowest point, which looks like if I had to eyeball it would be -2. Little strange, this topic. This trips up a lot of kids. So what you should probably do is watch this a few times and try to process this a little bit slower. The last thing we're going to do is not so hard. All right, last question. We're going to graph our first quadratic function, but given what? What is that called? That is called a restricted domain. That is a restricted domain. All right, so I want you to type that into your calculator. First thing we're going to do is we're going to graph the function. So x equals -b/2a. We're going to do -4 over 2 times 1, which is going to give us -2. All right, so in your calculator, we're going to grab some values, but the smallest value I want to use is a -6. I need the axis of symmetry point, which is my vertex, and the largest value that I want is going to be +2. Now, remember, since they're both included, these will be hard points, meaning you will not have arrows. You will not have arrows. So we can grab a couple more points from our table. -4 and 0 are good points to grab that are in between here. All right, so let's fill this out from the calculator. It's going to be 11, -1, -5, -1, and 11. You should probably put this in your calculator, hit your table of values, and just confirm that these are the points that we're getting. And I'm going to go ahead and graph these points. -6, 11. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right at the top. -4, -1. -2, 1, 2, 3, 4, 5. We are making the most of this graph, that is for sure. 2 through 11 all the way at the top. Now, we're going to bend it up, and we're going to come all the way up to our point. Do not put arrows. This is a restricted domain, so let's come all the way down towards our minimum point. We are going to graph our function with our equation, as always. And we are done as far as graphing this goes. And then we're just going to answer just a few quick questions with this. All right, the range. Now, this is a little tricky. The range, the lowest value it goes to is -5. And the highest value it goes to is 11, which you can see here. Range. Look at these values. What's the smallest y value? -5. What's the highest y value? 11. So our range is from -5 to 11. That should both be hard brackets there. You could also say it like -5 less than or equal to f of x, which is y, which is less than or equal to 11. Whether you want to use inequalities or this. If this is f of x, this should technically be f of x as well and not y, just so they match. But you remember, these are interchangeable. All right, when is this function increasing? Well, let me ask you something. I'm going to trace this from left to right. What does it look like it's doing? Decreasing, and then all of a sudden it starts to increase. So it's increasing at -2. Once we hit -2, and then we stop at +2. -2 to 2. It's increasing. Now, I have to use parentheses around the -2 because at the turning point, it's neutral. It's not increasing or decreasing. Not increasing or decreasing at the vertex. And then it's increasing, and that should probably be, it's increasing at this point. It's still increasing there. We just stopped the graph. All right, so that's going to be that. And lastly, is x equals 0 part of the interval for where f of x is greater than 0? Well, plug in 0 to the function, and you will get 0, -1, or you can just see it there. And you will see that x equals 0, you get a negative. So the function is negative at that location. All right, you might want to watch this video once or maybe even twice just to kind of comprehend a lot of this stuff. These are a lot of vocab words that kids have a hard time with. It will require some practice, so I highly encourage you go on the website under the homework section and print out all the practice problems, and please practice those on your own. Hit up those Castle Learning questions and email any questions or comment below, and I'll get back to you as well that way. All right, well, be well, and we'll talk to you guys soon.